Hello everyone. In this video, we are going to discuss about Cartesian products of sets from the chapter 2 Relations and Functions of class 11 Maths. You see, if we consider two sets, one is P and another one is Q. We are considering two sets P and Q, and the Cartesian product of these two sets P and Q, that is actually denoted by P cross Q. Okay, and it is defined as the set consisting of all ordered pairs. Ordered pairs are written in brackets like this. All ordered pairs P comma Q, small letter P and small letter Q, for which the small letter P, this actually belongs to the set capital letter P, and the small letter Q element belongs to the set capital letter Q. That is, the first element belongs to the first set P and the second element belongs to the second set Q. That is how we write the ordered pair P comma Q. And you see, this P cross Q, which is a Cartesian product of two sets, it is actually formed by pairing each elements of P with each element of Q. See, P and Q should be two non-empty sets. If either P or Q is a null set or an empty set, then the Cartesian product P cross Q will also be an empty set. Okay, that is, if P or Q, either P or Q is an empty set, then P cross Q, that will also be an empty set, that it will be equal to phi. Okay, so you see, by definition, the Cartesian product of two sets P cross Q, it is actually defined as the set of all ordered pairs P comma Q such that P belongs to P, the set P, and the element Q belongs to the set Q. Don't worry about the definition and all these statements. We will do some examples, we will do some questions so that you get a better idea about this. Now, suppose set A is a set of two colors, red and blue, and set B is a set of three objects, B, C, S. See, B for bag, C for coat, and S for shirt. Instead of writing bag, coat, shirt, we have just written it as BCS, that's all. Okay, so here, if you write the Cartesian product of A and B, that is A cross B, you will have so many ordered pairs within these braces. So the first ordered pair will be how? The first element in A is red, the second element in A is blue. Okay, now the first element in B is B, second element in B is C, and the third element in B is S. Now to write A cross B, what you want to do is, you just want to write the ordered pairs. In the ordered pair, you want to write the first element of A, that is red. Okay, comma, first element of B, that is B. Comma, next ordered pair, first element of A, comma, second element of B. Now, first element of A, third element of B. Okay, comma, first elements are over. No, now second element of A, blue, comma, first element of B. Okay, comma, second element of A, second element of B, comma, second element of A, third element of B. Okay, so this will be the set of A cross B. These are the ordered pairs. Okay, see, these are the ordered pairs, red comma B, red comma C. These are actually called as ordered pairs. See, ordered pair of elements taken from any two sets, A and B or P and Q. It is a pair of elements written in small brackets and grouped together in a particular order. See, order is important. This red comma B, red comma B, this ordered pair is actually not the same as B comma red. So the order is important. Now you see, this is how we represent the, the connection or the cross product of A and B. That is, you see, we have in the first set red and blue, the two colors. In the second set we have BCS. Okay, so A cross B will have elements red comma B, red comma C, red comma S, then blue B, blue C, blue S. Okay. Now consider two sets A and B. See, you can represent the sets with any capital letter, P, Q, R, S, or A, B, C, D, whatever the letter is, it should be in capital. Okay, it should be the capital letter, that's all. So here we are considering two sets. One is set A, another one is set B. You see, set A has these elements D, L, M, P, K, A. See, D, L represents Delhi, MP, Madhya Pradesh, K, A, Karnataka. And set B has these elements 0, 1, 0, 2, 0, 3. These are actually representing the codes for the license plates of vehicles issued by Delhi, Madhya Pradesh and Karnataka. See, if these three states are making codes for the license plates of vehicles with the restriction that the code begins with an element from set A, then which are the pairs available from these sets? See, the code should begin with the element from the set A, that is a restriction. So, the ordered pairs available or possible here are what? The first element in A, first element in B, that is DL01. First element in A, second element in B, that is DL02. First element in A, third element in B, that is DL03. Similarly, MP01, MP02, MP03. Okay, KA01, KA02, KA03. So these are the elements possible here, ordered pairs possible here. So these are the available pairs. So A cross B, that is the Cartesian product of A and B will be what? The set of all these ordered pairs. Okay, so you see this ordered pairs can be represented like this as well. Let this yellow colored lines are for D, L, M, P and K, A, that is the elements in first set, and these green colored ones are they are representing the elements in the second set B. So you see we have the ordered pairs, that is DL01, DL02, DL03. Okay, we have MP01, MP02, MP03. We have KA01, KA02 and KA03. Alright, now you see the number of elements in the set A is 3 and the number of elements in the set B is also 3. Okay, now how many ordered pairs are there in A cross B? Just count it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is, you see 3 3s are 9, no? Alright, so the ordered pairs in the Cartesian product of two sets will be what? The product of the elements in A and B. That is, you see, while we write the ordered pairs, the order in which these elements are paired is crucial. That is the code DL01. It is not the same as 01DL. Okay, that is the code DL01. It is not the same as 01DL. So the order is important. The first element is DL, second element is 01. If you interchange these elements, you are getting another one. Alright, they are not the same. Now, let us consider the other two sets. Set A is, has these elements A1 and A2. Set B has these elements. See, how many elements are there in A? 1, 2, 2 elements are there in A. How many elements are there in B? 4 elements are there in B. So we are expecting 8 ordered pairs in the Cartesian product of A and B. So let us write the Cartesian product of A and B, that is A cross B. See, first element in A, first element in B, first element in A, second element in B, first element in A, third element in B, first element in A and fourth element in B. Okay, similarly A2B1, A2B2, A2B3, A2B4. So these are the ordered pairs possible here. So how many ordered pairs are here in the, how many elements are there in the Cartesian product of A and B? 1, 2, 3, 4, 5, 6, 7, 8. Right? 8. Okay, so 8 ordered pairs are formed here. So here you see, let this yellow colored one, the vertical one, let this be the green colored ones. Okay. So let this yellow colored ones represent the elements in set A, that is A1 and A2. Green colored ones are actually representing the elements in B, that is B1, B2, B3, B4. So you see we have these ordered pairs A1, B1, A1, B2, A1, B3, A1, B4. Then A2, B1, A2, B2, A2, B3 and A2, B4. Okay. Now you see, if the set A and set B are subsets of the real numbers, then it is obvious that the point in the position A1, B2, that will be distinct from the point in the position B2, A1. That is, these two ordered pairs are not the same. Okay, that is, if you consider the positions of the point 2, 3 and position of the point 3, 2, these two positions are different, say they are not the same. That is, you see, if you consider 2, 3, so 2, 3, so 2, 3, this will represent 2, 3. This is the point which is representing the, the position of 2, 3. Then the position of 3, 2 will be where? So 3, 2. First element is 3, second element is 2. So this will be the position of 3, 2. So you see the positions are different now. Okay, so they are not the same. Similarly, A1, B2 is not the same as B2, A1. So order is very, very, very important. Now let us see some remarks. You see, the first one is, two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. That is, if we consider an ordered pair A1, B1, if it is equal to another ordered pair C1, D1, this is possible if and only if the first elements are equal, that is A1 is equal to C1, and the second elements are also equal, that is B1 equals D1. Okay, let us do one example. If the ordered pair x plus 1 comma y minus 2 is equal to another ordered pair 3 comma 1, then find the values of x and y. How can we find the values of x and y? We said that two ordered pairs are equal if and only if their corresponding first elements are equal and their corresponding second elements are equal. That is, you can equate the first element in the first ordered pair and the first element in second ordered pair. Similarly, you can equate the second element in first ordered pair with the second element in the second ordered pair. Okay, so here you see x plus 1 equal to 3. So x equals 3 minus 1, which is equal to 2. So the x value is 2. Similarly, you have y minus 2 is equal to 1. So y equals 1 plus 2, which is equal to 3. So the y value is 3. I hope it is clear to you. Now, let us see the second remark. If there are p elements in A, that is, the number of elements in set A is equal to P. N of A is equal to P means number of elements in A is equal to P. Okay. And if there are Q elements in the set B, that is, number of elements in set B is equal to Q, then there will be P into Q, PQ elements in the Cartesian product A cross B. That is, if N of A is equal to P and N of B is equal to Q, then N of A cross B will be equal to P into Q. That is, if set A has 3 elements, we will write N of A is equal to 3, and set B has 4 elements, then we will write N of B is equal to 4. Then the number of elements in the Cartesian product of these two sets will be 3 into 4, which is equal to 12. Okay, now let us see the next remark related to this, that is, if A and B are two non-empty sets, and if either A or B is an infinite set, that is, infinite number of elements would be there in the set B, then the Cartesian product of these two sets A cross B will also be an infinite set, that is, infinite number of elements will be there in A cross B. Okay. Now let us discuss the another one. Let A is equal to set ABC, then A cross A. Okay, A cross A, that will be the set of ABC such that A, B, C, they belong to the set A. Here, this A, B, C, this is actually called as ordered triplet. Let us see one example. Let set P is equal to the set of 1 and 2. Then form the set P cross P cross P. Okay, see how can we form P cross P cross P? See, P is actually set 1, 2. This P is also the same 1, 2. This P is also the same 1, 2. Right. So, to write P cross P cross P, this will be the set of, A, B, C. That means you want to take the first element of P, first element of P, again first element of P, that is 1, 1, 1, ordered triplet, comma. First element of P, first element of P, and second element of this P, third one. So, 1, 1, 2. Okay, comma, first element of P, second element of the second P, and the first element of the third P. Okay, comma, first element of the first P, second element of the second P, and second element of the third P, comma. Then 2, 1, 1, similarly 2, 1, 2, then 2, 2, 1, and 2, 2, 2. Okay, so this will be the set of P cross P cross P. Alright, so you see in set P you have 2 elements, but you are taking P cross P cross P, so 2 into 2 into 2, which will be equal to 8, no? So how many elements are there in P cross P cross P? 1, 2, 3, 4, 5, 6, 7, 8. Right. Okay. Now, let P be this set of A, B, C, and Q is equal to actually set of only one element is there, R. Now, what about Cartesian product of P and Q, that is P cross Q? You want to write the ordered pairs. First element in P, first element in Q, only one element is there. Then second element in P, element in Q. Third element in P, only one element is there in Q. So, this will be P cross Q. Now, what about Q cross P? When you write Q cross P, you have to write the first element of Q. Okay, as the first element of the first ordered pair. Okay, so first element of Q is R. Now the first element of P. So R comma A. Okay, first element of Q, second element of P, first element of Q, third element of P. Okay, so this is P cross Q and this is a set of Q cross P. So it is very clear, that is from the definition of equality of ordered pairs. You see the pair A comma R, it is not the same as the pair R comma A. So here it is very clear that P cross Q, this Cartesian product is not the same as Q cross P. However, the number of elements in each set will be the same, because you see the number of elements in P cross Q is 3, number of elements in Q cross P, that is also 3. Okay. Now, if A cross B is equal to, the set of ordered pairs P, Q, P, R, M, Q, M, R, then find A and B. So, you see A cross B, no? So, A, that is actually the set of first elements. Okay, so the first elements in these ordered pairs are P, P, M, M. We don't want to repeat the elements, so P, then M. Okay, so this will be the set A. Now you see, B is actually written here as second. So set B will be the set of second elements in this Cartesian product. So second elements are Q, R, Q, R. No need to repeat it again. So Q, R. So this will be the set B. So in this video, we have discussed about the Cartesian products of sets from the chapter 2 Relations and Functions of class 11 Max. I hope it is clear to you. Thank you.